Have you ever wondered how many oceans could possibly exist out there in the vastness of space? It's a compelling question, isn't it? We know the Earth is teeming with water, our blue planet, a jewel in the cosmos. But what about the rest of the universe? Could there be other places, other worlds where oceans ripple and waves crash? Let's take a journey, not too far from our home, to Jupiter, the colossal giant of our solar system, surrounded by a symphony of moons. Among these moons, there's one that's particularly intriguing, Europa. Now you might be thinking, a moon? That's no place for an ocean. But that's where the story gets interesting. Europa, smaller than our own moon, is believed to be home to a vast subsurface ocean. That's right, an ocean hidden beneath a shell of icy armor. But this isn't just any ocean. It's estimated to be twice the size of all of Earth's oceans combined. Can you imagine that? An ocean twice the size of our Pacific and Atlantic, Indian and Arctic, all concealed beneath the icy crust of a moon orbiting Jupiter. But what makes this ocean even more fascinating is the potential it holds for life. We know that here on Earth, where there's water, there's often life. Could the same be true for Europa? Could this distant icy moon be a haven for extraterrestrial life forms? It's a tantalizing thought, isn't it? Scientists are eager to explore Europa's hidden ocean to unlock its secrets, and perhaps to answer one of humanity's oldest questions. Are we alone in the universe? The prospect of life on Europa is a thrilling possibility, a testament to the extraordinary and diverse potential of the cosmos. So next time you gaze at Jupiter in the night sky, remember its moon, Europa, might be hiding a world of water beneath its icy surface. Did you know that space is not as silent as you might think? Space, the boundless, seemingly quiet expanse above us, is teeming with sounds. Now you might be wondering, how is that possible? Isn't space a vacuum? Well, you're right. Space is a vacuum, devoid of air and matter, and sound, as we know it, requires a medium like air or water to travel through. So when we say space sounds, we're actually talking about something a bit different. In space, sounds are captured in the form of electromagnetic vibrations. These vibrations occur as a result of the interactions between celestial bodies and their environments. For instance, our very own sun produces vibrations from the tumultuous activities happening on its surface. These vibrations, traveling in the form of electromagnetic waves, reach us here on Earth, millions of miles away. But how do we hear these vibrations? Enter NASA, the world's leading space agency. With the aid of specially designed instruments, NASA scientists have been able to convert these electromagnetic vibrations into sounds that our ears can comprehend. Imagine for a moment being able to listen to the roar of our sun or the whistle of a distant black hole. It's a little bit like tuning into the universe's radio station, isn't it? These space sounds are not just fascinating to listen to, but they also serve a vital scientific purpose. By studying the frequency and pattern of these sounds, scientists can glean valuable information about the celestial bodies producing them. This can aid in understanding the composition, activity, and even the history of these distant objects. So the next time you gaze up at the night sky, remember this. Those twinkling stars and silent moons are not as quiet as they seem. Their electromagnetic vibrations, converted into audible sounds, are like the universe's symphony playing continuously, eternally in the vast concert hall of the cosmos. So, while space might seem silent to us, it's actually filled with the music of celestial bodies. What if we tell you that if you could drive your car upwards at 60 miles per hour, it would only take about an hour to reach space? Imagine this, but on a cosmic scale. You see, space is big, unfathomably big. But when we talk about distances in the cosmos, we often use the speed of light as our yardstick. The speed of light is an astounding 186,282 miles per second. Yes, you heard that right. That's about 7.5 times around the Earth in just 1 second. It's a mind-boggling speed to consider. Even at this breakneck pace, light takes time to travel across the vast expanses of space. For instance, the light from our closest star, Proxima Centauri, takes over 4 years to reach us. That means the starlight we see tonight is actually a glimpse into the past. It's the light that left Proxima Centauri over 4 years ago. Isn't that something? We're looking at stars through a sort of cosmic time machine. But let's bring it back home for a moment. Even within our own solar system, the speed of light puts distances into perspective. Although the sun is about 93 million miles away, light from the sun takes just over 8 minutes to reach us on Earth. And if we were to send a light signal to Mars, it could take anywhere between 3 and 22 minutes for it to arrive, depending on our planet's positions. These vast distances and the finite speed of light remind us of our place in the cosmos. They highlight the vastness of the universe and the limits of our current technology. But they also inspire us to push those boundaries, to reach further, and to explore the cosmos as never before. So, while space might seem far away in the grand scheme of the universe, we're closer than you might think. And who knows? Maybe one day we'll find a way to traverse these cosmic distances in the blink of an eye. Have you ever heard about the invisible matter that makes up about 27% of the universe? Yes, you heard that right. There's an elusive entity called dark matter that pervades the cosmos, unseen and largely undetected, except for its gravitational effects on galaxies and galaxy clusters. This isn't a science fiction concept, it's a reality in modern astrophysics. But don't let the name fool you. Dark matter isn't dark in the traditional sense. It doesn't absorb, reflect, or emit light, thus remaining invisible to our telescopes. This is why we call it dark. But if we can't see it, how do we know it exists? Great question, and the answer lies in its gravitational effects. You see, galaxies spin far too fast for their visible mass. According to the laws of physics, they should be tearing themselves apart. But they don't. Something unseen is holding them together, acting like a cosmic glue. And that invisible something, we believe, is dark matter. The existence of dark matter isn't just a haphazard guess. It's supported by a plethora of indirect evidence. For instance, when we observe how light bends as it passes massive objects, a phenomenon known as gravitational lensing, the calculations suggest there's much more matter than we can see. Again, pointing towards dark matter. Yet despite these clues, dark matter remains one of the greatest mysteries in astrophysics. We know it's out there, influencing the structure and evolution of the universe. But we don't know what it's made of. Is it a new type of particle yet to be discovered? Or is it something else entirely? These questions are at the forefront of scientific research, and the answers could reshape our understanding of the universe. While we can't see dark matter, its influence is undeniable, shaping the universe as we know it. So the next time you gaze up at the stars, remember, what you're seeing is just a fraction of the cosmic story. The rest is shrouded in the mystery of dark matter. Let's take a moment to marvel at the mysteries and wonders of the universe we've uncovered today. We've journeyed from the intriguing frontiers of our own solar system to the edge of what we can perceive, exploring the vast cosmos and its awe-inspiring phenomena. We began our journey with the captivating prospect of Jupiter's moon, Europa. Underneath its icy surface, scientists believe there lies an ocean twice the size of Earth's oceans. This tantalizing feature of Europa isn't just a spectacle, but it also holds the promise of potentially harboring life. Imagine that a moon, not a planet, could be a cradle of life, much like our own Earth. From the possible oceans of Europa, we ventured into the realm of the sounds of space. While space is largely silent due to the vacuum, we've learned that there are indeed sounds, vibrations in magnetic fields and charged particles, which we can convert into audible sounds. Our universe, it seems, has its own symphony, played out in the grand theater of the cosmos. Next, we delved into the astounding concept of the speed of light, a fundamental constant of the universe. The speed of light not only defines how we understand time and distance, but also sets a cosmic speed limit, a boundary that seems impossible for us to cross. Yet it's this very boundary that fuels our curiosity and spurs us to push the limits of our understanding. Finally, we grappled with the enigmatic mystery of dark matter. This unseen, undetected substance makes up approximately 85% of the universe's mass. It neither emits nor absorbs light. Yet its gravitational effects shape the cosmos in ways we're still trying to comprehend. As we conclude our cosmic journey, let's remember that these are but a few of the countless wonders that the universe holds. As we continue to explore the depths of the universe, who knows what other fascinating discoveries await us?